Lesson 18.3, Task 3. Solve quadratic equations using the quadratic formula. The quadratic formula can be used to solve any quadratic equation in standard form. If the equation is not in standard form, you will first need to rewrite it. Then determine the values for a, b, and c and substitute them into the formula. Alright, the steps for solving the equation x squared minus x minus 6 equals 0 and the justifications for each step are shown below, but their orders have been scrambled. Match each solution step to x squared minus x minus 6 equals 0 with the step number so that the solution steps are in the correct order. The letter D represents the discriminant, which is b squared minus 4ac. So the letter D is just going to represent the discriminant. All right, so that's right here. All right, so let's see. In step 1, what do we need to do? Well, we need to identify our A, B, and C since it's in standard form so that we can plug this into the quadratic formula. All right, so let's go ahead and work this out ourselves first, and then that will give us a better idea of what steps we're looking at. All right, so let's start by writing the equation down. X squared minus x minus 6 equals 0. And then A is my coefficient for my quadratic term, so it's a 1. When there's no number there, it's assumed to be a 1. The number for the linear term is B, and it's a negative 1 because it has a negative sign. And our constant term is our number is negative 6. All right, so remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So if you know the quadratic formula and you know what a, b, and c are, all you have to do is plug in the numbers and then simplify. So let's go ahead and do that. Negative b, so the opposite of b is opposite of negative 1 plus or minus the square root and b squared minus 4 times a times c. A is 1, c is negative 6, and all of that's over 2a. All right, so the next step, so I'm going to simplify. So negative 1 becomes just 1 plus or minus, and the square root of 1 is 1, or square root of 1 or negative 1. Sorry, the square of negative 1 or 1 is 1. I'm saying square root, but all I'm doing right now is evaluating what's under the square root. So negative 1, quantity squared, anything times itself is going to be a positive number. So negative 1 squared is 1. And then negative 4 times 1 times negative 6. Two negatives make this a plus 24. And then 2 times 1 is 2. So now I can see that under the radical term, which is called the discriminant, 1 plus 24 is 25 over 2. And then I can say 1 plus or minus the square root of 25 is 5. It's a perfect square. 5 times 5 is 25, so I know the square root is 5. And then that's divided by 2. Now, this plus minus means I have two solutions. I'm going to come over here to finish. So I have x equals 1 plus 5 over 2. And I have x equals 1 minus 5 over 2. So what I did was take this step, and I did 1 plus 5 and 1 minus 5 to get these two equations here. So I can simplify those. So this becomes 6 over 2. And I went ahead and wrote 3. So this is 6 over 2 or 3. And then this is 1 minus 5, so negative 4 over 2. Which is negative 2. So I'm going to have x equals 3 or x equals negative 2. So those are my two solutions. All right, so what we want to do is kind of look at what we've done here and see which steps need to be done in which order. So step 1, we identified our A, B, and C. So we can say step 1, A, B, and C. Step 2, we substituted into the quadratic formula. So all we did was substitute all the numbers in. Remember, they're saying D represents this right here. So D represents the discriminant. So that would be this step here. The next step would be to simplify or clean up some of this. So negative times negative becomes positive 1. So this kind of simplifies some of those things there. And then the next thing would be to take the square root of 25. So that would be this step here. So all they did was take the square root of 25. So evaluate the square root. And then we're going to go from here to set up 2 equations. After we did this, then we wanted to set up 2 equations. So that's going to be this step. And then the last step would be our solutions. All right, so see how it kind of helps if you know how to work it out, and then it kind of gives you those steps there. All right, so step 1, what did we do? Step 1, we chose our A, B, and C. Step 2, we found the quadratic formula. So step 1, identify A, B, and C. Step 2, substitute into the quadratic formula. All right, for step 3, they simplified each of the terms. So the negative, simplify each term. Because that's when we went from negative 1 to 1. That's when we evaluated underneath the discriminant and multiplied in the denominator. So simplify all terms, which means you're just going to simplify throughout the quadratic formula as much as you can. All right, step 4. All right, that was simplifying the radical. Okay, they're calling it evaluate the square root. So that would be this one. And then step 5, after evaluating the radical, then we set it into 2 equations. Rewrite as 2 equations. And then simplify both equations. All right, so what we did was solve the quadratic formula here and go through the steps. And then in B part, all we did was justify each step. Okay, so justify each step. All right, the solutions are 3 and -2. To verify the solutions, use a graphing calculator, y equals x squared minus x minus 6, and choose the phrases to explain how the graph verifies the solution. So you can see they've typed it in. Here's the quadratic equation, and you can see it crosses the x at -2 and at 3. And you can see our solutions are -2 and 3. So it says the x-intercepts are the solutions. This is because these are the numbers where y equals 0. So this is your y-axis, and you can see that y is 0 all the way across through here. Okay, so your x-intercepts are the same as when your y is 0. All right, how would a graphing calculator help you verify real solutions that are not integers? All right, so you could get an approximation of those. If you graph, you could check to see if it's close. If this was a radical that couldn't be simplified, you could type it in and get a decimal, and then the same thing, get an estimate by graphing and see if that decimal is the same as your solution. And that would be the best way to check it, using a graphing calculator. All right, that's all for task 3. If you have any questions, let me know.